Number 1 here, I would change this to 6x to the 1/2 instead of the square root minus 5. So to integrate this, you're going to add 1 to the exponent of 1/2, that would be 3/2. Then multiply the 6 by the reciprocal of 3/2, which is 2/3. This 5 is 5 times x to the 0. If you add 1 to the exponent, it would be x to the first. Reciprocal of 1 is 1. 5 times 1 is 5. Throw in your arbitrary constant. So cross-canceling, you can divide 6 by 3 and get 2. 2 times 2 is 4. That gives us 4. X to the 3/2, we want to put it in the original form, which was a radical, would be the square root of x cubed. And then minus 5x plus c. There's number 1. Number 2, I would change the square root of x cubed. I would change that to 5x to the 3/2. Just changing the way it looks, so finding the antiderivative is simpler. To find the antiderivative, the rule is you add 1 to the exponent. So 3/2 plus 1, that would be 3/2 plus 2/2. 3 plus 2 is 5. So that's x to the 5/2. At the 5 that was there originally. Then we multiply that 5 by the reciprocal of 5/2 and multiply it by 2/5. Subtract 6. This x has an exponent of 1. Add 1 to it and you get x squared. Multiplied by the reciprocal of 2, which is 1/2. And you throw in your arbitrary constant. This simplifies. Multiplying and dividing by 5's cancel. Over here, 6 times 1/2 gives us 3. So we're going to get 2 square root of x to the 5th. I think it's best to put that in radical form since the original problem was. And then minus 3x squared, and then plus your arbitrary constant. This next problem, number 3, technically I should do brackets around this. It's going to be in your best interest to multiply x minus 4 times x plus 4 before you try to integrate. So this is going to give us x squared minus 16. If you use the FOIL method, you end up with a plus 4x and a minus 4x in the middle, and those cancel. Now to integrate this, simple. Add 1 to the exponent, multiply by the reciprocal of the exponent. Add 1 to the exponent, multiply by its reciprocal. 1 times 16 is 16, plus your arbitrary constant, and this is our answer. And we don't actually need this to the first here, that was just for emphasis. Number 4, at first glance you might think, well, I have to use substitution for this because we have this fraction. Well, it's not true. You can divide each term in the numerator, there's 3 of them, by the denominator. So 3x cubed, we could divide by x. We could divide 2x squared by x. We could divide 4x by x. I'll show you a different way to organize that work if that doesn't make sense to you. And that's the following. You could factor an x out of the numerator. It's equivalent to what I'm showing here in this, and actually probably like this better. But either way you do it, continuing, you're going to end up with 3x squared plus 2x plus 4. If you organize your work like I did over here on the right, the x's cancel and you're left with the same thing. Then integrate it, add 1 to each exponent for the variable, and then multiply it by the reciprocal of that variable. Multiplied by the reciprocal of the exponent. Don't forget your arbitrary constant. You end up with x cubed plus x squared plus 4x plus c. You can always check your answer by taking the derivative of the answer, and you should get the original problem. Number 5. This is a special rule because it's e to a function. Specifically, it's e to a linear function. Might be best to change the way this looks to say e to the 1/2 x, which means the same thing as x divided by 2. So the rule here is you take the reciprocal of the coefficient of x. So our exponent here is 1/2 x. It's a linear function because it's x to the first. You take the reciprocal of the coefficient of 1/2. The reciprocal of that's 2. Leave the e to the 1/2 x the same. Then you add your arbitrary constant. That's it. It's real simple if you know the rule. If you don't know the rule, then it's not so simple.